Hi everybody, today we're going to start talking about friction. We've been talking about friction in class, so we already know that it's a force that exists and it's one of the forces that we look at when we're determining the net force on an object. But now we want to see which factors influence the size of a force of friction exerted on an object. So our objectives for this lesson are to be able to define friction, to differentiate between static and kinetic friction, and finally to be able to define the coefficient of friction, which is something we use to express how rough or smooth the surface is. Alright, so first of all, what is friction? Hopefully you realize from class that it's the force that opposes motion or the tendency to move when two objects are in contact, meaning their surfaces are coming in contact because friction is a contact force. The idea of it opposes motion when an object is moving sort of makes sense to us. If we're pushing something in one direction and it's moving in that direction, that object is also experiencing a force of friction that is in the opposite direction of motion. But there's also friction when we try to move an object in a certain direction. So say, for example, you're trying to move a couch across your living room floor. When you apply a force to it and it does not move or change its motion, there has to be a force that's balancing out your applied force, and that force is actually a force of friction. So if we see that we try and push that lawnmower across the grass, there's two opposing forces. That's the big deal. You have to remember that these guys are opposing, so the net force overall exerted on this lawnmower is going to be less than the applied force, because some of that force in the direction of motion is actually balancing out the force of friction that the object is experiencing as it moves across the surface. There are several different types of friction, but we're only going to look at two in class. The first one is kinetic friction. Kinetic friction opposes the motion of an object sliding or moving across a surface. That's what that word kinetic means. It indicates motion. So there is some type of motion occurring as this object is on a surface. Static friction is friction that acts upon an object that is not sliding or not moving, but there is a force being exerted on it to try and tend it to move in a certain way. Static means no change. So as a result, we have no change in the object's motion, but there has to be some type of force balancing out, maybe an applied force that's being exerted to try and move an object, and that is static friction. And they're the two types of friction that we're going to look at. So how do you determine the size of the frictional force exerted on an object? Well, the magnitude depends on two things. The normal force supporting the object on the surface that is sitting upon, whether it is moving or not. So that, remember, has something to do with the weight of the object. And then the nature of the surfaces that are in contact. Are they rough or smooth or slippery? We all know that it's easier to walk on the sidewalk or the road or dirt or grass than it is to walk on ice. And that's because there's less friction on ice than there is on those other surfaces, because ice is a much smoother or more slippery surface. So how we describe the nature of those surfaces, or meaning how rough or smooth they are when they interact, we use something called the coefficient of friction. The coefficient of friction is represented with mu. All right, it's that Greek letter mu. You might have recognized it from when we talked about prefixes for the metric system. Mu is also used to represent the metric prefix micro, 1 times 10 to the minus 6. But in this case, when we're talking about friction, mu should be considered the coefficient of friction. And the coefficient of friction is calculated by taking the ratio of a frictional force exerted on an object divided by the normal force exerted on an object when two objects come in contact, and there is either motion over one or a tendency for motion over one. There are books and books and books and books of coefficient of frictions for different types of surfaces when two different types of materials come into contact. So you can look, for example, here, there are several. Rubber on concrete that is dry, rubber on concrete that is wet. There's a whole bunch of them. But you might notice that there's also two types of coefficients given. One is a kinetic and one is a static. That's because if you think about when you move an object or try to get an object moving, sometimes you have to apply a different amount of force. If you think about moving that couch across your living room floor, it may feel like there's an awful lot more force required to get the couch moving than it is to keep the couch moving once it already has gone into motion. And that's represented by the difference in these coefficients of friction, the kinetic or the static. And you can see from some of the examples here that the kinetic force, or the kinetic coefficient of friction, is often less than the static coefficient of friction. And that's because usually an object will experience less friction as it's moving over a surface than when you're trying to get it moving as it sits on a surface. The other thing you might want to notice is that the more slippery the surface is, the smaller the coefficient of friction is. So if you look at something here comparing, for example, the rubber on concrete, which you would think is a pretty rough surface on a pretty rough surface, that coefficient of friction compared to, say, Teflon on Teflon, and we know Teflon is what is used in our frying pans to create a non-stick surface, a lot more slippery, you can see that the Teflon on Teflon has a lot smaller coefficient of friction, which indicates that the object is going to experience a lot less friction on that surface than it would on perhaps another where the coefficient of friction was higher. All right, if we know the coefficient of friction then between two types of materials, we can then also determine the size of the force of friction that's going to be exerted on the object. And we simply rearrange that equation for mu into the force of friction equals mu times the normal force. Now, the coefficient of friction is dimensionless. It has no units because you are taking a ratio of force to force, so the units cancel out. So as a result, when you multiply mu times a force, you still get a force. So you want to make sure that you can rearrange that equation and make sure that you realize that you are getting a force as a result of your multiplication. So you can see also from this that the more weighty an object and the more normal force that has to be provided by a surface in order to support it, the more frictional force an object is going to experience as it moves over that surface. And that's just in the relationship of the equation. Okay, let's sum it up just to make sure you know which to use when. Now, if we have a frictional force that exists and we have no motion, we must have static frictional force. So we have static friction. Our acceleration is 0, meaning that we have no change in motion. So as a result, we must have a frictional force that is balancing out whatever applied force we are applying or exerting on our object. Now, in this case, that static frictional force will increase or change to balance out the applied force so that there is no net force on the object and the object doesn't change its motion. But surfaces can only hold on so much. So you might know when you are trying to push that couch across your living room floor, you can push, nothing happens. Push a little harder, nothing happens. Push harder still, nothing happens. That static frictional force is adjusting its size to balance out your applied force. But there's a certain point where you can apply a force that is large enough that it's going to overcome that maximum amount of static frictional force the surface can exert, and the couch is going to start to move. That maximum amount of frictional force that the surface can provide is determined by using frictional force equals mu times the normal force. But you notice we use this little subscript s. And that's just letting us know that when we're talking about the static friction, we have to use the static coefficient of friction. So when we're talking about the maximum amount that a surface can exert as far as a static frictional force on an object, this is what we're going to figure out. So we would know that we would have to apply at least that many newtons of applied force in order to overcome the maximum amount of static frictional force a surface can exert, and essentially our object will then break free and start to move. When that happens, we now have motion. motion happens, we have kinetic frictional force. Now, the thing that's different about kinetic frictional force is it does not change. It is a constant, regardless of how the object is moving across the surface. Is it moving slowly? Is it moving quickly? Is it moving at constant velocity? Is it accelerating? Doesn't make any difference. So the kinetic frictional force is not like the static frictional force in the fact that it will adjust. It is a value simply because the object is in motion, and you can calculate that using the kinetic coefficient of friction. So if you need to know how much kinetic friction an object experiences that moves across a surface that is in motion, you have to use a kinetic coefficient of friction. Now, there are some things that you can look at based on that kinetic friction being exerted on the object about how the object will move. If you apply just enough force that you are balancing out the kinetic force of friction exerted on the object, you have no acceleration, right? You have constant velocity. If you do not exert a force great enough to balance out the kinetic force of friction, you're going to have some type of negative acceleration or some type of slowing down of your motion, because your friction force is opposing motion, and if it's providing the net force, your net force is going to oppose motion, which means your velocity and your acceleration in different directions, and you're slowing down. If your applied force is greater than the kinetic friction, that means that your net force is going to be in the direction of motion. So as a result, you are speeding up. So this way means I'm pushing something, and I'm pushing something hard enough to balance out the kinetic friction, and I'm also providing more force on top of that to give a net force to accelerate the object as it moves. So it's very important that you realize the difference between static and kinetic. Static friction, there is no motion. You must use the static coefficient of friction in your determination of the force of friction, and it can adjust the size of force of friction based on what is happening as you exert a force on it to try to tend the object into motion. Kinetic force of friction is only when the object is in motion, and in that case it does not change whether the object is moving in constant velocity or accelerating. The size of the kinetic force of friction is the same all the time the object's in motion, and we use the kinetic coefficient of friction to determine that size. And then depending upon the relationship between our applied forces and our frictional forces tells us about what the net force is and how the object is going to change its motion.